The record is started now. Okay. So what is the use of this OSI? To create a network or to understand function of a network, to troubleshoot a network, we should understand the OSI model. Really, OSI model never, it's not any model like it is directly we build and deploy kind of stuff is not there. OSI model for each and every layer of this OSI model indicates certain functionality in the network. If you are sending a request and you are getting that one. So for example, I open a web page. So then it will display something on my screen. It means, so I send a request to my remote data web server. So I send a request, I'm getting that one. I'm sending a mail request so I can able to see the mail. I'm sending a mail, I receive a mail, right? I receive a internet connection means like I can access the websites, I can access the YouTube videos. All are from somewhere it has to be started and we have to get it, right? So that is how this network communicates. So that is how it is going on. Understanding of those things we call it as we use this OSM model for understanding. Okay. So this is a simple. I'm getting this again. Charging, no point of charge. Yeah, now it is something it is showing. Okay. So OSI, Open System Interconnected. It means whatever the operating system you are using, whatever the type of hardware you are using. Okay. So it make you connect and communicate. Understand whatever the model, networking model you are using, we can able to understand the communication between the devices with the help of voice model. And this voice model is standardized by ISO. Okay, it contains 7 layers. It's a, you can also call a set of protocols. It is a reference model. Voice model is reference model, networking model. What is the use of OSI? Irrespective of what hardware or operating system you are using, irrespective of what devices or cables or no cables you are using, we given a open, understandable, functional protocol set. That is voice model. So don't worry, it is. So voice open system interconnect. So here we have a 7 layers. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer it is. Still, it's not coming out. Now it is very good. Okay. So these first 3 layers are called software layers. The bottom layers, the bottom last 3 layers, we call it as hardware layers. The layer numbers are in this order only. The physical layer is layer 1, layer 2 data link layer, layer 3 network layer, layer 4 transport layer, layer 5 session layer, layer 6 presentation layer, layer 7 application layer. But I am reading from 7 to 1. The point is, guys, certain textbooks, some people may teach you from application layer to physical layer. Some people teach you or some textbooks will tell you from physical layer to application layer. Which one is you are habituated? That one is you can take it for understanding. But by functionality, it is always application layer to physical layer because first of all, you have to send from your system to outside, from your system to network, right? So what is happening at the network, I don't mind about. First important is what I'm seeing at my system, my device is an important. I open a website. I want to know what is things are there in the my website, right? I want to send a mail. I will think about my mail communication only. It is in my perspective. The first point is application point. Okay, I'm sending a request, and I will see the result again at application layer only. Okay, so that's it is. It is always best practice if in case if you are not habituated to any order, so always better to start from the application layer to physical layer. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. It is 7 layers. And we discussed about the devices. So hub is a physical layer, switch is a data link layer, router is a network layer. Okay. Transport is, of course, it is also part of software layers only, but transport layer also we call it as heart of OSI layer, end-to-end connectivity. Those things we will discuss. Of course, I told in a starting today class that is disk like a for connection we need a cables and NIC cards, and then we needed devices to connect to it. For communication we need an IP address, protocols, and an application, right? IP address we are already discussed. Then we will discuss about a protocols, because the protocols layer is the main protocols layer is at application layer only. So I will explain the application layer, but before that one, better I will talk about a protocols. Guys, what is protocol? Protocol is set of rules, and that is common. Any place you go, what is a protocol? Set of rules. What are the rules? No one knows. Okay, but here it is in our network communication. The protocol represents as a type of communication. What type of communication? So we are always said connection, communication, connection, communication. What is meant by communication? Mail communication. You send a mail, receive a mail. Okay. You send an instant message. Messaging. Messaging is also one of the communication. Ping request, pinging to the destination. That is also a type of communication only. Sharing of data, communication. Sharing of printer, or like a sharing of resources means sharing of printer is a communication. Okay, sharing of data, um, um, authentication, centralized authentication to the devices, remote access. I have a remote server. I want to access from my PC using SSH protocol or TELNET or DP protocol. I want to upload a file or download a file. Web page accesses. Okay, accessing Java T point. Facebook.com access, YouTube.com access. Okay. So these are all types of communications only. But how you will define like what type of communication you want to do with your remote system? You want a connectivity, you want to upload a file, or you want to send a mail, or you want to synchronize your time, or maybe you want to request for authentication, you want to access their web pages, or you want to send us some ping request, like echo request. Okay, what type of communication you want to do it? So you have to tell by that protocols. Use HTTP means you want to access web pages. It is, I want to see this web page. I send HTTP request. Okay, HTTP request. I want to send a mail, SMTP request. I want to connect remote, SSH or TELNET or RDP. I want to retrieve my mails, POP3 IMAP protocols. I want to upload or download a file, FTP protocol. I want to synchronize my time with a Centralized time server, it is NTP protocol. LDAP, Kerberos protocols for authentication protocols. Username, password authentication protocols are Kerberos LDAP protocols. Remote deployment, I have 100 computers, I want to install OS through the network in all my 100 computers. Okay, so that is boot P. We use boot P. Okay, DHCP protocols. And DHCP protocol is used by DHCP server to configure the client devices IP addresses. Okay, like this, these protocols, each protocol defined for a certain type of service or a certain type of communication. Each protocol represent a specific type of network service or maybe a specific type of set of communication. That is what protocol it is. Of course, we know the protocol for system understanding. We use the port numbers. Okay, we are understanding protocols, but for system, we use the port numbers. Each protocol has certain port number. Okay, I listed some of the most common protocols we use in regular communication. So I listed out, and it is also an important one. HTTP protocol, port number is 80. HTTPS protocol, port number is 443. HTTP, HTTPS, both are for web-related communication. You want to access a remote websites, so then we use HTTP or HTTPS. HTTPS is a secure because it's HTTP or SSL. It means the data is encrypted when you are using HTTP. HTTPS data is not encrypted, and HTTPS is data is encrypted, so data is secure. FTP 2021 to use for upload or download a file. SSH for remote access with encryption. Remote access security thing. I have a remote Linux server. I want to access from my system, so then I use SSH. TELNET, remote access file. RDP, remote desktop access purpose. 3389 is a protocol port number for remote desktop purpose. SMTP 25 port numbers for sending mails. POP3 and IMAP for retrieving the mails. 110, 143. TFTP port number is 69. It's a trivial file transfer protocol for uploading, downloading configuration file or backup the configuration files of remote servers, routers kind of stuff. DHCP is a protocol used by DHCP servers to assign or configure IP addresses to the client PCs. Port number 6768. DNS is a protocol used by DNS servers and DNS clients to resolve the remote server IP. Please. Okay, the DNS server. For example, I opened www.java.tpoint or www.youtube.com, studio.youtube.com, docs.google.com, mail.google.com. I do not know those servers' IP addresses, but all communications by IP address only. So how can I get an IP address of docs.google.com, learn.microsoft.com, www.youtube.com, www.facebook.com, mail.google.com? How can I get there? Server's IP address. My system send a request to the DNS server to get an IP address of it. So my DNS server will give me an IP address of it, and then I can communicate with the server with an IP address. For example, in my system, I open www.javat.point.com. I don't know their IP address. Immediately, my system send a request to the DNS server. The DNS server returns an IP address of www.javat.point.com. Okay, that is a DNS protocol. Domain name, system, port number is 53. NTP, Network Time Protocol. So you can synchronize your time with your remote time server. So if you go to your time, click on the time, and right click on the time, adjust date and time. You can see your time server. You can see the time server, time.windows.com. Based on your time zone, this server will set the time based on its lifetime. Okay. You want to correct your analog watch time. What you will do, will go to find a standard time and then you can change it like from TVs or maybe from railway stations. Okay. Earlier people put a railway station. Now railway station time is different now. Okay. Smart mobile phone, if you have, you can see there and you can adjust it, right? Okay. Here it is also like we can follow a centralized time server and we'll get the time sync based on it. In this example, I showed a Microsoft Times.windows.com will synchronize the time. Kerberos and Delta are used for authentication protocol. Kerberos mainly for Microsoft Active Directory service base. Okay, authentication protocol when user can be login anywhere to the centralized authentication system. SNMP, Simple Network Management Protocol for remote monitoring purpose. Okay, so this is 161, 160. Other than these regular protocols, I added three more protocols, guys. That is MySQL 3306, Tomcat 8080. It is generally everyone knows Tomcat 8080. Generally, it use that protocol. 8080 is used by so many protocols, different type of services, but mainly web-based related. But Tomcat is also using 8080. It can be changeable, not fixed one. So Oracle DB DNS listener port number is there. If you have an Oracle database server outside of your local system, it is there in the network, but you want to connect to the network. So you need to use this protocol. So 1521. Okay. So this is about a protocol. What is meant by protocol? Defines what type of communication. Is it web related communication, mail related communication, okay, file upload or download related communication, remote access related communication, okay, remote machine access related communication, okay. So like that, what type of communication you want to do it, so we will use that protocols. So that is the correct part. Guys, understand protocols?
Yes, sir.
Yeah, very good. Guys, you look at here. Here
Yes,
we
sir.
start with an application. Good. Okay. Application layer. Of course, I already told about protocols, then we can directly understand this application. Application means to communicate in the network. Of course, already connection is there, and then there is an IP address, but from which interface you will communicate. Okay, you want to send a mail, so you need a mail related kind of interface, right? For example, Outlook is a mail client application. You can use the mail client application to send and receive the mails. Or web browser also you can send and receive the mails. What is the purpose of web browser? To access the websites. What is the purpose of Outlook? To access the mails. What is the purpose of an application like PuTTY? For remote access, remote connection. What is the purpose of FileZilla kind of application? For FTP protocol, remote upload and download. Like this, we use an application either client side or server side to communicate. And how you? With a defined protocols. Okay, the client send a HTTP request to the web server from web browser. At web server, there is a server. Are there like a Tomcat server is there, HTTPD server is there, NGINX server is there, MSIS servers are there. Like a different application make a server as a specific type of server. Okay. So if you install Tomcat in a server, it is a web server. You install NGINX in a server, it is a web server. If you install Apache HTTPD, it is a web server. If it is a Microsoft Windows server, you can install MSIAS server, Microsoft Internet Information Services. It become web server. Same goes like a mail servers. You take a server and install a Microsoft Exchange application inside, it is become a server. Install a Zimbra application, it's become mail server. Like that, guys, in the application layer is talking about application part of your communication. So from where, which application you use to communicate and what type of communication. So that is also you have to choose it. Okay. Require that application on it. WinSCP to upload, download files to the remote Linux servers from your Windows system. Okay. Like use protocols like a VSFTP, SFTP, SCP. Okay, so these are the things. Okay, so here it is application layer is about application. Okay, like a web browser or Outlook or maybe PuTTY is also an application. Okay, at a client side and as well as the server side applications and its protocols. What protocol use to communicate? Based on the protocol communication only, we choose that application. You don't use web browser for synchronizing the time, right? Let's understand application layer.
Yes, sir.
So presentation layer. What is the presentation layer? So yes, now you use an application like you are using a web browser and you are trying to send a request to the remote web server. Or you are a web server, you are sending a response to the client. Either which ways, you are sending a data and you understand what is the request by the protocol and you are responding and you are sending data. Okay, this data will be encoded when you are sending. Data is encoded. The data is in the different formats. System don't understand all the formats, right? It is change the format to the standard format, means ASCII format. Okay, it encode the data. Then data is size is bigger, so it will compress the data, make it smaller. So for it is for easy transport purpose, it compress the data. If you use a protocol, encryption type protocols like SSH, HTTPS, okay, VSFTP, not SFTP or VSFTP, RDP. So data will be encrypted. Definitely depends upon encryption type of protocol use. The encryption is also applicable. Not only that one, guys. Telnet is not encrypted, but still we can encrypt it. Okay. So when there is an encryption, so data will be encrypted. So this is presentation layer. Encoding, decoding, compression, decompression, and encrypting, decrypt. So this is the presentation there. You guys understand presentation layer?
Yes, sir.
Next is session layer.
Yes, sir.
Here, when you are sending a request or a response, you are responding to some request. Okay. So there will be a session. Session means a session will be created. A session will be created and it will be maintained till you receive complete information, complete transaction of your data, complete process completion. For example, you go to the Amazon and you want to buy something, you open the Amazon app and go to some goods, add to cart. Okay. So once it is everything is final, then you will go for a buy. You click on buy, select address, select your UPI pay type of payment or maybe credit card type of payment. You select it, then you go. So what will happen? These are all maintained with the same session ID. Okay. So once you are into the payment, that is very important. You may have an experience in it. That's why I'm telling this one. So when you are going for a payment, it will shows a message that is, do not press the back button or refresh the page. I will tell you what happened. So when you are send payment, so then payment, entire this payment will happen with your session ID only. The payment request go to the bank. In bank, it will check your balance and detect your balance, transfer that amount to the Amazon with your session ID only, with your session ID and transaction number. Session ID and transaction number will be sent. This is the amount detected for bank, credited to the Amazon by this session ID. And Amazon verifies who is the person login, who is the customer using this session ID, and then so you will add the amount like yes, amount is received, order is placed. Amount is paid. For example, you refresh or you press the back button. What happened? Of course, for money detection, request went, and again it detect your money transferred to your Amazon. May not be transferred to Amazon. So because of meanwhile you've done a refresh or press back button or you done a refreshment or you are disconnected from internet. When Amazon receives, it does not know whose money it is because of next session ID is different now. Your next session is different and that different. It does not know who's paid amount now. Okay. So it is not credited to Amazon, but it is debited from your bank. So what happened? It will take some time to retrieve the money. Maybe in 3-4 days, it will verify the money is not transferred to anyone. So then it will be transferred back to you. That is the main importance of session ID, guys. While session is going on, till the entire complete transaction completed, the session has to be maintained. Once it is completed, it automatically terminates. And also, with the session layer, is also do the authentication. You open a website. So I've opened a website. So to access anything from the server, we need a authentication, right? So your access like a anonymous user or with some specific user identities. Okay, certain user role you are as a certain role you are accessing. That is important, right? For a in a network. I told about website, but you want to log into Gmail account. Gmail website is anonymous. Anybody can open Gmail website. But log into the Gmail account, again you need to give username and password. So in the session ID, it attach your identification. It create a session and then It attach your identification, your required information, your request will be attached to your system and send to your destination. Destination understand what are your information, your data, your authentication information, verifies it is your authentication and reply to your with your session ID only. So then you will receive complete information. Complete transaction will happens. That is a session layer. Session layer, you will create a session, maintain the session, terminate the session, authenticate, authorize the users. And entire transactions happens which is attached to your session ID only. You download a data, how you can able to download data? The data is attached to your session ID till the session is alive without any interruption. The session is going on, data will be downloaded. Any session, any interruption is occurred at a network, the session ID will be gone and your download will be stopped. Yeah, tell me guys, someone is trying to ask question. Okay. Yeah, the session layer is a little bigger, but very important. For writing, it is very less. Okay. So then I'm going to the transport layer. Before going to the transport layer, guys, okay, this is application layer, presentation layer, session layer, transport, network, data link, and physical layer. Application layer, what are the outcome of application layer? Okay, so what are the things you use? Like what are the outcome? That is a data only. Okay, what are the application layer? It is a data. Okay, so the layer data we call it as PDU. The layer data we call it as PDU, packet data unit. Whatever the layer it is and what are the data in it. That is what we call it as PDU, packet data unit. So the data in the application layer is called data. That PDU name is data only. Even it is compressed, encrypted, okay, and encoded. It is a still data only. The PDU is data. Session layer, it is also we call it as data. The PDU we call it as data. This is gave to the transport layer. Transport layer take this data and segment the data. It segment the data. It chop the data into multiple parts. Minimum is 64 bytes, byte or bit. So I will check it. Okay. For example, this is my sentence I am sending. Example purpose only, guys. Not really, this won't happen like that for our understanding. It will segment the data, it will chop the data into small pieces and send the data by one. So here it is, how it is happen. It segment the data. It segment the data. Okay, it numbering the data and numbering and sequence on the data. So what happened here, it is this is the source and this is the destination. The source will send each and every segment to the destination. It will send to the destination. When the destination receives, it gives an acknowledgement. I received this packet. I received this packet. Like this, destination give an acknowledgement. For example, I send second, Then first one sent, second one is sent, third one is sent, fourth one is sent. So for third one, I didn't receive any acknowledgement, but fourth one, I received an acknowledgement. Meaning source understand, first one is received, second one is received, fourth one is received, third one is not received by the destination. It means the destination received these packets. Hello, how, you. These only packets are received by destination. What source is doing? Source will send the packet again. Which packet is missing? That packet only it will send. And it receives acknowledgement. So then what it is? Like this. So now you destination received, hello, how you are. But actually what I sent, hello, how are you? It is different, no problem. Because this numbering and sequencing, it arranges the data back to the normal. Means again, it reconstruct at a destination because all our data is sent. All these can be easily constructed because of session layer. Session ID with all these chopped data send with a sequencing order plus session ID. It will check session ID. This session ID, it collect all the packets and arrange the packets as per their sequence and numbering. And once it is entire data is collected, it will send to the presentation layer like that. Okay. So this is segmenting. So transport layer has a very big thing. Okay. So transport layer do the segmenting. Segmenting means chopping the data into small pieces and give the numbering and sequencing on it. So then it can be arranged at the destination. So this is because of this, it is error correction. Error correction occurs at transport layer. Error correction occurs at transport layer, not error detection. Error correction occurs at transport layer. Okay. So any data points are missing while it is transmitting the pieces. Anything is missing. So the source understand the specific part is missing. It will resend. Once everything is collected at a destination, destination rearrange the data. So that is what it is, error correction. Okay. Next one is TCP IP. It will multiplex TCP IP protocols. It means, as we discussed about a protocols, each protocol either TCP type protocol or UDP type protocol. TCP type protocol or UDP type protocol. Okay. So for example, what is TCP? Transaction Control Protocol, UDP, User Datagram Protocol. For example, you take STTP. STTP is TCP type protocol. SMTP is TCP type protocol. FTP is a TCP type protocol. DHCP is UDP type protocol. TFTP is UDP type protocol. DNS is UDP type protocol and as well as TCP type protocol also. Some protocols are TCP type protocol, some are UDP type protocol. What is meant by type of protocol? TCP type, UDP type. Guys, you have a source and the destination. And if you are using TCP type protocol means source send a packet to the destination, destination will send an acknowledgement with respect to it received a packet. So its meaning is the source understand destination is received a packet. Like source send a packet. When destination is received, destination send an acknowledgement. The source understand the destination is received a packet. Okay. In case source does not, source send a packet, destination is not received or fail to send acknowledgement, the source or source not received acknowledgement from the destination, the source thing destination is not received a packet. Okay. See, it meaning is source knows destination is received a packet or not. What is an acknowledgement? In the earlier days, now still also there, even though in online application formats also we have an acknowledgement. Once you fill all the application and you paid the amount, finally you done submission, right? Final submission and payment done, and you will get a receipt, right? Your application submitted successfully with your application ID, and you will get an acknowledgement. That is a proof that is you are applied, right? That is an acknowledgement. In our olden days, when we are applying for even this MSET, GATE examinations, any examinations, we have to purchase first application, and we have to fill the application. We have to attach this acknowledgement and we have to do the registration post. Once the at receiving side, once they receive the application, they will send that acknowledgement card to us. It is a proof that you are applied and that at destination they received application. So that is your acknowledgement. Here it is in the TCP type protocols, send packet to the destination when the destination receives, and it will, the destination send an acknowledgement that source understand destination received a packet. Guys, understand the TCP type protocol work.
Yes, sir.
UDP type protocols. What are the UDP type protocols we'll do it? Like DHCP, DFTP means source send packet to the destination, source send a packet to the destination. And source does not know is destination received or not. If even case destination not received, source does not know destination is received or not. It has to send packet anywhere. So that's why UDP protocols are compared to TCP protocols are faster. Compared to TCP, UDP type protocols are faster. It does not require to wait for any acknowledgement. It keeps sending packets. But UDP is a non-reliable, connectionless protocols. Non-reliable means source does not know destination is received or not. If destination is received, good. Not received, you don't know. If you know, you will send it again, but you don't know. You didn't check destination is received or not. That's it is non-reliable. Connectionless. Anyway, it is a connectionless because the destination is not telling to anything to you whether it is received or not. You have keep sending. Nothing you didn't ask. Do you understand or not? Do you received or not like that? Okay. That's it is connectionless. Yes, connectionless does not mean wired or wireless type of connectivity. Connectionless means from source to destination, there is no connectivity. No connectivity means no acknowledgement connectivity is not there. Source does not know, destination is received on that. And TCP is a reliable. Why reliable? Source knows destination is received our packet based on the acknowledgement. TCP works based on the acknowledgement. Source received a packet or not. Okay, acknowledgement. And TCP also called as connection oriented. Why connection oriented? Because the destination is keep telling you, I received a packet, I received a packet, I received a packet like that. So you will understand. So which packet is received, which packet is not received, and you can correct it at it. But what happens at the transport layer, guys? So this is the main difference between TCP and UDP. Very important question. OSI model and TCP UDP. Very common interview question. Okay. Otherwise, I can tell what is OSI model in a single lines. It encapsulates while you are communicating, use different types of protocols. You use HTTP protocol, FTP protocol are inside, DNS protocol, DHCP protocol, right? So what are the protocols you are doing in a particular session? You're doing what are the protocols? These protocols are multiplexed under TCP and UDP. So TCP type protocols if you are using in the communication, it multiplexed under TCP. If any UDP protocols also used, it multiplexed under UDP or encapsulated under UDP. You can say like that also. So that is what happens inside your transport layer. What I said, segmenting. Second one is TCP, TCP and UDP, TCP, UDP segmenting, sequencing, error correction, TCP, UDP, and flow control. What is meant by flow control? Guys, you have a 1 Gbps connection. You have 1 Gbps connection, and destination is 100 Mbps connection only. Yours is 100 Mbps connection. And the destination is 100 Mbps only. 1 Gbps to 100 Mbps. You can send packets very fast, but receiver cannot receive that much fast. It may be busy with other things also, possibilities there, right? Even both are having same speed. So what is this transport layer will do? It estimate how many packets the destination can able to receive. How many packets you can able to deliver, that is secondary. How many packets the destination can able to receive at a time. So based on that, the source will send the packets. So that is called a flow control or windowing. Okay, both are two different methods. Flow control and windowing is both are different methods, but still almost all same. Concept is same. Okay. So guys, here it is what happened. As I said, in the transport layer, what are the data is segmented, sequencing and numbering, and then TCP, UDP encapsulation or multiplexing kind of stuff thing is happens. Then flow control. So everything they will put it in one header packet called a TCP header. This TCP header packet part contains information about your segments, sequence numbering, encapsulation information, and flow control information in this one. And this one is added to your PDU. Means the data layer things. Means what are the data is here that will be here. Okay, it is TCP, it's attached to it. So this PDU, this is a total packet, the total packet data unit, we call it as a segment. The total packet, we call it as a segment. This segment is sent to the network layer. The segment is sent to the network layer. In the network layer, what happens? Guys, understand transport layer?
Yes, sir.
What happened at network layer? Network layer is all about a network related, means at logical addressing or routing. Two informations. One is routed protocol information or routing protocol information. So different networking models use different types of logical addressing. IP addresses, IPv4 or IPv6 or SPX, IPX. So like that, different type of networking models use different type of logical addressing. So whatsoever it is, it's a logical address part, routed protocols. Routing protocols. So of course you have to communicate to outside, right? So like you want to transfer your data from your device to another device. So you have to tell which way you have to communicate. Through the default gateway or through within the LAN you have to go send a packet or through the default gateway you have to send it. Or maybe it is from one router to another router. This is a way of destination. So like that, it is which way, how it should be reached the destination. That information is routing protocols, right? So in a network layer, it add your source IP address. Okay, routed protocols. We are using IP address models, so it adds source IP, destination IP, plus your segment. Of course, also your routing information means how to reach the destination information to your segment. The total information, the total packet, the total PDU, we call it as packet. So transport layer packet. Transport layer PDU is a segment. That segment is sent to network layer. At network layer, source IP address, destination IP address, and network route information added to your segment. Okay. Then this total PDU we call it as a packet. The packet is sent to the data link layer. Guys, completed network layer. Data link layer, two layers. Logical link control, media access control. Two layers are there. So this LLC is for WAN connectivity. For example, guys, this is not always between the two computers. This is from any point of device to any point of device communication. So, for example, you have a Wi-Fi router, you are connected to ISP, means for you are trying to establish a WAN communication. Your request for a WAN connectivity from your router to your ISP. So then once it is connection is done, then you will receive internet, right? Different types of connectivities are there. So like a PPP, okay, point-to-point Ethernet. So point-to-point connectivity from one router to another router, HDLC protocol, frame relay, MPLS. This is the different WAN protocols used to connect your routers in the WAN communication, either in your regular internet or maybe in a private WAN communication itself. If you are using ACT, it's a PPP OE, point to point over Ethernet. Okay, next. In case you are using WAN connection type of communication, it is also include WAN connectivity. It means what type of connection, what type of protocol, WAN protocol you are using to connect. That information is also added here. Of course, you know the MAC address. What is the MAC address? Your NIC having a MAC address. So it adds that if in case if WAN type of communication it is, you are using connectivity with the WAN, so then WAN type of protocols will be added. Otherwise, just normal. So source MAC address, destination MAC address added to this packet plus CRC plus CRC. Cyclic redundancy check. MAC address, source MAC address, destination MAC address, packet, and CRC. These are all as a one's packet contents. Okay. So your packet contains source IP, destination IP. In the data link layer, it add source MAC address, destination MAC address, add to the your packet plus CRC. What is this CRC? Cyclic redundancy check for checking errors. Data, when you send it, other side it will receive, no? So when it is received data, it verify the data, make sure that data is good or corrupted. While you are transmitting data, so data can be corrupted, right? Possibility. So At a destination, it check the data with your CRC value. With your CRC value, it check your data, make sure data is good or corrupted. If it is corrupted, it drop the packet. So where data error checking is happened at data link layer using CRC algorithm. CRC is a algorithm used for error checking purpose. This whole data we call it as frame. This whole packet data unit we call it as a frame. That frame sent to the physical layer. Guys, understand data link layer?
Yes, sir, we got it.
No.
Yes, sir.
Last one is physical layer. Okay. What is this frame will happen at physical layer? It converts this frame to bit stream. And this bit stream again convert depends upon what type of interface you are using. For example, you are using our Ethernet, then it is electrical signal. If you are using some fiber optical type of connection, it is light waves. The bit stream convert into light waves. For example, you are using Wi-Fi. Then it will signal, it convert into radio signal with a 2.4 or 5 gigahertz radio signal it will convert. So this is the finally your OSI model. Totally 7 layers. It's a network model it is, and it is a reference model to understand and maintain and troubleshoot the network related issues. Okay, we have application layer, presentation layer, session layer, transport, network, data link, and physical layer. Yes, when you are sending, and you always follow from application layer to physical layer. When you are receiving, it's a physical layer to application layer. For example, you take PCA and PCB. You send some request. Simple, you are doing some ping command. Ping command use ICMP protocol. Okay, like that. Or maybe you are sending a web access request, or maybe your remote connectivity request. So your side, you need an application. Yeah, okay, your side, you need an application to do the send request. You need an interface. What is an application? Application is an interface for you to get whatever you want to access. That is your application. It can be web browser, or it can be a Outlook, or it can be some PuTTY application or mobile external application, anything, right? It's an application. And how you will request with some protocols, related protocols. Either you know the protocol, or maybe it is already written there about a protocol. So very simple. At a destination, the destination understandable application. So what based on your request, the service related application must be there. Okay. Now source application layer will start giving some request or sending information. What presentation layer do? It encode the data, compress the data, encrypt the data. Session layer attach a session ID and send user information who is requested their information, credentials. It will send and attach the required information also. Okay. So this session ID go to the transport layer, and with the data, along with your data, the session ID also will go to the transport layer. The whole data will be segmented. The whole data will be segmented into small pieces, numbered. Okay. Also TCP and UDP protocols will be encapsulated there, attached to your packet as a TCP header to your data. TCP header is added to your data. So that is your transport layer segment. That segment went to the network layer. The network layer that has source IP address, destination IP address. If required, the routing, default routing information. So the packet has to go directly within the LAN, or it has to go to the default gateway. that information is added. And this packet data unit, we call it as a packet, and the packet sent to the data link layer. If packet is sending over WAN links, then it is WAN related information is also added. But if it is in the local LAN, so it only MAC address will be added. The MAC address is a media access control. It is given on your NIC. Source MAC address and a destination device MAC address plus your packet plus your CRC. Cyclic redundancy check is an algorithm to verify your data for error purpose. Okay. Is it corrupted or good? Like a error correction or a error checking purpose. This CRC protocol used. Okay. So this CRC number will be added here at the end of the PDU. So total we call it as a frame. The frame sent to the physical layer, and physical layer converts this frame into bit stream. Bit stream convert into signal. Okay. Think like we are using some hub or a switch type of connection, and we using a Ethernet connection. It is an electrical signal. Guys, understand up to here this entire story up to here this part.
Yes, sir.
Now we will discuss about a receiving
Yes,
side.
sir.
Okay. So I received a signal at B. I am at B now. Okay. I received electrical signal. So I will convert that signal into bit stream and bit stream to frame. At physical layer, the electrical signal converted into bit stream to frame. The frame again converted into not doing anything. So the frame is sent to data link layer. What is this data link layer will do? It will move, it will check the frame. It checks source IP and destination, sorry, source MAC address, destination MAC address, and it save the source MAC address in the ARP table. Of course, tomorrow, if possible, next time I will explain that one, but try to remember. It save the source MAC address in the ARP table and verify the destination MAC address. If it is belongs to the B, it accept it, and also it use the CRC value to verify your packet. Make sure that the frame is not corrupted. The data is not corrupted. So with the help of this CRC value, it runs this is corrupted or not. If it generating error, it drop the packet. No errors, it accept the packet and send the packet part to the network layer. Okay. It is filter all the things and the packet is sent to the network layer. The network layer check the packet, source IP address, destination IP. It save the source IP into the ARP table. So it has source IP address, source MAC address means PCA IP address, PCA MAC address also. Both IP address and MAC address. Now destination learns. Okay. Now what happened? This network layer check the source IP, destination IP. Verify the destination IP with the base IP or not. If it is same, then it accept the packet. If not same, it drop the packet. Okay. Then it extract the segment sent to the transport layer. But segment is one part. We have lot of segments, right? So that's why it is transport layer is heart of OSI layer, end-to-end connectivity. End-to-end connectivity means at transport layer only, it collects all the segments. Because your PCA sending, initially it is a data, now it is segment, all the segments only. Maybe it can be 5 segments, 10 segments, or 100 segments. Okay, all are pieces only. All these pieces will be collected at the transport layer. How system understand these all pieces are belongs to same segment because of again session ID. So it will collect all the segments and order all the segments in the one sequence order. It club all the segments as one single packet. And it will save the session ID, and also it a session ID in the it will send the session ID to session ID session layer, and also authenticate which user is sent, is anonymous user or with certain user name, verify the user credentials. Okay, and de multiplex the TCP UDP kind of stuff at transport layer. It send all the data to the session layer to presentation layer, but data is encoded, so it is decoded here, decrypted and decompressed at a presentation layer. And finally, the actual data what is generated from PCA is given to the PCB application. For example, you are sending a mail. You're sending a mail, and at other side, the mail server is required. Okay, server side application is required. Like other side, receiving application also, like you are sending with an application, other side receiving application also required. So it will understand what protocol you use, what application has to be responded to you. It will understand what is your request, what is you wanted, what is data you are sending with the help of that application and the protocols. Then once it is understand, it will try to give a response to you. Again, from PCB, it starts application, presentation, session, transport, network, data link, physical. Okay, either it is top to bottom. When you are sending application to physical, when you are receiving physical to application. Just understand this at the destination part, PCB side. Hmm? No one is speaking. Alar ganar what?
Yes, sir.
Very okay. So read compulsory about your OSA model, guys. Each layer, each protocols, each layers, and each layer data also important. So for example, so what is the transport layer PDU? What is the packet from the transport layer is segment. What is a data from network layer is packet. Okay. What is the data from data link layer, or what is a PDU from data link layer is a frame. It is in physical layer bit stream. Okay. So devices, okay, layer functions. Yeah, all these things are important. Okay. Compulsory read. So because the tomorrow, because it's already 5:45, without knowing ourselves, we are went to that much time. Okay. And we will discuss about the difference between TCP/IP OSA model. With the help of OSA model, how can we troubleshoot and how to connect devices, testing. Okay, all these things required protocols, IP addresses, and the connectivity related. Okay, so those things are required, and OSA model understanding also required. So compulsory read today at least about the networking related OSA model, IP address, devices. These three, please compulsory check it once. Okay, we'll meet you tomorrow. We'll discuss.
Yes, sir.
That's it for today. Any doubts or any questions, you can ask me.